Okay. Hello, everyone. My name is Maurice Kalinowski. I do work for the Qt company, where we develop Qt. Most people in Germany call it Qt. Inside there, I'm the maintainer for the Qt MQTT module, meaning implementing the MQTT protocol. And that's also the reason why I want to talk about MQTT 5 in this respect. I usually like to start with a short questionnaire to get everyone on a common ground. So whom of you has first-hand experience with MQTT? Okay. Who does know at least about what MQTT is? And publish and subscribe patterns are known, or? Okay, that's okay. So I guess I can be very quick on the publish and subscribe. So basically it's, you have lots of clients connected to one server. After they are connected, they are basically subscribing to a topic hierarchy. In that case, topics T1, T2, and you can use wildcards, which then means that everything which is starting with topics, everything below, that wants to get the notification. So whenever then the client on the left side is publishing data, that data is then duplicated on the server and sent to everyone who's being interested in that. Okay, in that context, why do you want to use MQTT? First of all, and I believe it's one of the most important aspects, is that it's an open standard. So you're not relying on somebody who's having it in the closed and might be developing that in a pattern you're not interested in. When we're talking about programming languages, etc., you have many implementations. So you can choose whatever implementation which fits for your need. That also goes for different licenses, etc., etc. And MQTT being used already in quite a large extent, there's quite a lot of interoperability with cloud providers, etc., etc. One of the aspects which is also interesting is that OPC UA are basically, or aiming at being the de facto standard in industry automation. For the next version, they have agreed to use MQTT as the standard for their publish and subscribe. First of all, being coexistent with AMQP, but it seems like they are focusing on MQTT for the future. What specifies MQTT in itself? I saw that is basically quoting from the standard in itself. I think the important items are that it's claiming to be lightweight. I've been talking about open already. It claims to be simple. Supposed to work in constrained environments, which is usually then meant for sensors and in the IoT field. One-to-many, that's obviously then the publish and subscribe parts. What differentiates it from some others is you have a free quality of service levels, which means that you can then send a message either as a fire and forget, which is usually what happens from a sensor. Here's my temperature or humidity or whatever. You have QoS level 1, where you get an acknowledgement from the server. Okay, this has been handled, or this has been received. And level 2 then means that you do basically a longer communication in terms of being used, for instance, in transactions. So you send something to the server says, I've received the message, okay, have you handled the content? And then the server says, yes, it's handled. And then you know, okay, you can forget about that message. So once again, open standard by the Oasis. You can always read like, the progress on there. But when it claims to be lightweight, what does it actually mean in the actual content? So what defines it lightweight? First of all, obviously, you want to have a minimum overhead of data for your messages, because in the sensor network, you have very limited, if you're considering low-pan networks, etc., you only have a very limited bandwidth. And as such, the protocol in itself you're using when to send your messages should be as limited as possible. So from the demo from the example you've seen before, the three patterns I've used: connect, subscribe, and publish. What you can see basically there is, if you look at the byte stream, the first byte, or actually the first half of the first byte, defines the command. You then get basically like how long is that command to be. In the connect statement, it says I'm an MQTT in this and that version. You have a fixed set of properties you're already sending. So that means like flex to set, keep alive specifies when, okay, this is my where I want to have a ping, or where I'm going to send a ping if the connection is still alive, etc. And then you basically start with the payload, which is username, password, and whatever you have in there. For subscribing, once again, the pattern is the same. You have length. You're subscribing with a topic length. That then might be of varying length. As you, for instance, see in that easy pattern, it's A/B. So that's 3. In addition to that, you have the topic length, which then would only be 1 byte. But the interesting aspect is that this is a variable byte integer. So the maximum size is it can use 4 bytes then for the size, but it tries also to reduce that once again to reduce the overhead. That basically summarizes all the commands you have in MQTT 4. So we've been talking about connect, you get the acknowledgement, you want to publish something, you get the acknowledgement, that was for QoS1. And on the other hand, then for QoS2, receive, release, complete, etc. Subscribe, acknowledgement, unsubscribe, get acknowledgement, ping pong. And for the very rigid people, you might actually want to disconnect once you're done. My experience is that people not do that. So that's like the brief overview of MQTT 4. So what has happened now in 5? And given the time I have, this is the amount of features according to the standard which have been added. And I'll only focus on a few of them. But taking it a bit back, so the standard aims to be as simple as possible. And now that you recognize that, okay, we have sensors which have obviously way different requirements on the protocol than, for instance, if you have a server somewhere sending something around, we have way more resources, etc. How can you make this protocol then fit for all these use cases? And especially, you would still want to keep the protocol as, well, low level or as easy as possible. And the idea now has been to introduce properties which are added to the commands on a need basis. We're going to go back to the byte stream example later on. But the idea is that for each of the 3 commands I've been showing, you are now able to set quite a lot of, well, properties. The session expiry basically implies whenever I'm disconnected, or if you use a sensor which has a flaky connection, like this monitor apparently, whenever you have a flaky connection, that the server does not consider you to be disconnected just because the underlying connection got interrupted, and when you reconnect, you need to do the negotiation again. So the session expiry basically takes care, like, okay, there might be a gap of 5 seconds or something. Receive maximum is basically implying how many messages you are able of taking care of in parallel. More importantly, and that's an interesting use case, is maximum packet size, which defines what's the maximum size of a message I can actually receive. And we've been talking about, well, memory constraints already. And there is that one example where you have, for instance, an MCU trying to connect. And you can have, for instance, retained messages. So whenever somebody connects, the server already sends a message. And that message is bigger than you can handle on the MCU. What happens then is that, well, it disconnects and says, oh, sorry, no, that's not able. I cannot do that. But then the sensor tries again to connect, and it gets that message again. So you're getting into, well, basically you lost your sensor. And the idea with maximum packet size is that while you are connecting to the server, you say, okay, this is the maximum I can receive. If you have bigger messages, disregard them. I just don't want to know about them. Topic aliases, I'm going to get into detail later on. And well, basically for subscription IDs on the subscribe side, there's an example. So that's basically the amount of properties you have. And when we go back to the byte stream example, so what basically has, it's getting a bit, what has happened is that these properties theoretically have been added now towards the end of the variable byte header. So you do not need to specify them, but if you want to, you can easily extend that one by one. Again, you need to specify the size, how many properties are there, and then you have basically a mapping of an ID for instance, the 27 for the maximum packet size, and then basically 4 bytes to specify the maximum message. And that way you can use all these properties I've been showing on the previous slide, but if you're not interested into that, you still can keep the messages as small as possible. And if you're not using any of that features, the maximum overhead you get is 1 byte per message, because you need to specify that you have no properties included in the message or to be sent. In terms of embedded, what's important there, I've been already talking about session expiry. Message expiry also is important, because you might not necessarily be interested in a message which takes ages or is ages ago. So that you can basically take care to not receive those messages. A will delay. For those who are not familiar with MQTT, you can also specify a will message, which means whenever I'm disconnected, please send this as a last message, basically a testament. That is usually a, oh, sorry, I'm disconnected message. You can then publish to all the other subscribers. It's basically stored on the server itself. Once again, when we're talking about flaky connections, you're losing your connection accidentally and everybody gets notified that you're disconnected, but while you're actually not, so you might get into some application logic problems with that. So with the will delay, you can specify that. I've been already talking about the example on the hardware limitations. And for the bandwidth limitations, we're talking, I want to show you the topic aliases. So topic aliases is very important once again when you're talking about sensors, etc. I've been showing you the byte stream in itself, but the typical layout for topics is like you have your sensors which are located in Europe, you have some kind of UUID to specify it, and you need to specify what type of data you're basically sending in a message, like for instance temperature. So when you're looking at that, the topic then itself is 64 bytes. So whenever you're sending a message with a temperature, which just contains those 28.4 degrees Celsius, maybe, you need 71 bytes for that. And that's not necessarily what you can claim as minimal overhead. So with topic aliases, you basically add in something as well in between, so that you can specify properties. That's a 2, which is the alias. The 23, and you give it an ID calling 1. I'm basically using this topic and I declare to be an ID. During the connection, you need to obviously negotiate. Is the server capable of handling aliases? Are you? And once that is done, you know how many IDs you can use as a max. So in that case, at the first time, you need to use 74 bytes to send the data, but every following time, you basically can omit the whole topic name and just send the ID. So afterwards, you're down to 11 bytes, which means that the second time you're sending a message, you already spared quite a lot. Another item which has been requested quite heavily is to put some more focus into authentication and authorization. MQTT 3.1.1 or MQTT 4, how it's mostly been referred to, relies on TLS. And basically lets the underlying transport take care of everything. In the optimal case, you have username and password in a connect statement, but that's about it. So that's not very flexible, call it like that. Especially it caused then vendors who were creating server solutions to create their own solutions on top, potentially breaking the standards and then providing their own clients, which are not according to the standard, but were then providing authentication as well. So for MQTT 5, the idea was we need something in there. And when you look again at the available commands, there is still for half a byte 1 command left. And that's the authentication command you can now use as well, which is bidirectional, also between client and server. That still might be complicated because it's not like you're sending data once, you get something back, and then you're authenticated. Usually you want to have like also round trips, etc. So what you can do in the auth command is that you specify, I'm going to continue the authorization. Then again, the client continues the authorization, and you go back and forth and back and forth. And at one point in time, you're hoping that you are authorized and can continue to work. In addition to that, once you have handled that, you can also take care of ACL. So when you look at the topic hierarchies, the brokers or the servers are now capable of having user-specified topic access, so that you can specify which user, which has now been authorized, is able to read, write to a certain topic. That can also help. Especially in terms of, not in terms of, but the next item is error handling. Version 4 mostly says that if an error occurs on either side, disconnect. That's when we're talking about debugging and what has happened with the whole connection. That's pretty complicated to know what has happened and what has been wrong then while you were sending data, because there is no mean in MQTT4 to get an error message. Some might claim that this is a security feature, but then again, while you're developing the product, you might be interested in knowing what's happening. And what has been introduced there is reason codes and reason strings, but strings I haven't been seen in action so far yet that much, mostly because, well, it's a string, and the code might indicate already quite clearly what has happened. That could be a non-authorized ID or whatever. So that you're able, within each of the commands and each of the steps, know if something fails, basically you can react to that. For debugging purposes, subscription IDs are very useful. Overlapping subscriptions is an example. So while you're a subscriber, you could basically say, okay, between the connection between me as a client and the server, I'm the ID number 1. And you have, for instance, if you have a client which has 2 subscriptions, you would use ID 1 and ID 2. So in that case, on the right side, you are subscribed to a very specific topic. On the left side, you're using a wildcard. What happens now is when the server is trying to send you a message, you will be notified that there is already another subscription from your very own client which gets that data as well. So if you want to reduce the data transfer rate, you already know, okay, you should know who created which IDs, but you can then at that point react to the fact and take care that you basically refactor your code, that you only need to receive that message once. So much for what has been now added in 5. Let's talk a bit about downsides of MQTT. So not everything is most awesome. The requirements on the transport below is pretty high. I've been talking already like TLS, we just rely on whatever is being used below. The requirements are that it's ordered, lossless, bidirectional, which already rules out, for instance, UDP. And that is also why most people use TCP and not I'd say 99.9% it's TCP. And TCP can be very heavy, especially when you have something which basically is trying to send sensor data within every half an hour and then is supposed to get down as soon as possible. Getting the whole TCP stack up to send 28.4 degrees and then going down again is too expensive. From what you're reading right now, that is considered for version 6. There is no timeline on that at all. If you are acting in that field, there is a derivative, let's call it like that, MQTT SN, SN for sensor network, which has removed that dependency, so that could, for instance, work via UDP. But as such, it's not a finalized open standard, so you might lose some other of the benefits we've been talking about before. Server as the bottleneck. When we're talking about sensor networks, usually you're talking about large scale, tens of thousands, hundreds of thousands of sensors, and you have one server. That obviously doesn't necessarily scale up that well. So you could consider using clusters, which then need to interact to each other, or creating bridges, which then forward the message, etc. The standard does not claim anything on that topic. So once again, you are now in a situation where you need to rely on that vendors are taking care of that. That is something which should be taken care of as well. And then also load balancing, usually, well, you could consider that a cloud-specific item, but you need to basically take care that all these clusters then still are pretty much in shape. Having implemented quite some projects, what I usually get as negative feedback, and in my opinion that's completely unrelated because we're talking about publish and subscribe, is that you're not able to do remote procedure calls, like with gRPC or etc. And another thing, that you're not able to know whom you are talking to, which, well, is a completely different design. If you want to know whom you're talking to, you should create a direct connection. There is one addition as well, and that is when you're using shared subscriptions. So consider the case you have one publisher, and on the other side you have a couple of subscribers which are sharing a subscription. That clarifies that only one of these shared subscribers will get that message. So basically you're trying to remove duplicates of the message, and as such you then have the chance to have many basically worker subscribers who then take care of whatever a message content is, evaluate it, and then move it on, so that you don't need to duplicate that. For version 4, if you search on GitHub or whatever you want, there's quite many implementations already. Version 5 now being standardized beginning of this year, especially with the problem that on the server side, that's the 3 ones I've been finding so far. It's at a starting point right now. Luckily, I was writing the Python one as well. It seems to have quite some traction here. But I guess this list is going to get higher and higher. The most prominent implementation is PAHO. And the testing utilities is basically their testing framework they're using. So they have a test framework already for testing MQTT5, but PAHO as a library provider has not started on MQTT5 yet. Also, I wasn't able to find any information on what their scheduling on that is. As a last example, one thing I wanted to at least briefly mention. So far, when you're talking about MQTT or publish and subscribe, you're in a situation where you have sensor and somewhere there's a server you need to talk to, etc. What we are recognizing on our embedded customer case, where usually the hardware is a bit more potent, is there's a rising amount of customers using container technologies on the devices as well. And while that gives quite implicit security features, you still need to handle the situation where these containers are then supposed to talk to each other. And what we've been recognizing is that publish and subscribe patterns are very useful in that respect as well. So you're basically taking then the server part of MQTT on the device itself, that it's more like a local connection. And when you're then basically talking about the transport requirements, bidirectional, lossless, etc., you could easily then come up with other patterns which don't necessarily require TCP as the underlying item. So that's more like food for thought. But that summarizes basically the brief overview of the new items. If you want to read the standard, that's the link to the Oasis. I also recommend, if you have time, to watch Ian Craigs, who's basically one of the most prominent people on the standard, where he has been talking about also the evolution of MQTT5 and why they decided to implement certain features the way they did it now. So that's really a worthwhile look as well. Yeah. Questions?
No questions? Thank you.
Thank you.